Hello and welcome back. In this video we are starting a new series where we will learn how to make Python predict data. This is the basic idea behind machine learning, but we're going to keep everything simple and build it up step by step so that you can clearly see how it works. So let's get right into it. To understand what we are going to do is building the building blocks into how to start working with AI and the real foundations, even for models that we use nowadays. First, we import libraries we need. So we import NumPy so we can work with arrays and matrix operations, and we import pyplot from matplotlib so we can visualize the data and our predictions in graphs. Next, we load in our dataset. This is slightly different to how we did it in previous videos, but we want to download it as a NumPy array. So to do this, we use car_data equals numpy.loadText, and then in brackets, the file car_data.txt. We make sure this dataset text file is in the same folder as the Python code. However, if not, we can always use the directories. This file contains two columns of data. The first column is the engine size of a car, and the second column is the fuel efficiency. So we're going to separate these into two variables, x and y. X equals car_data, then inside square brackets colon, comma, 0, and y equals car_data, square brackets colon, comma, 1. X will store the engine size column and Y will store the fuel efficiency column. In machine learning, this is a very common setup where X is your input and Y is the value we're going to want to predict. Perfect. Next, we create a loop that runs 1 to 8. N will represent the power of the polynomial we're going to be using to predict. So therefore, this loop is going to increase the complexity of our prediction model. Each time the loop runs, we create a new polynomial that tries to fit the data with the highest power n. Inside the loop, we create something called a Vandermonde matrix. I hope I'm saying that right. x_Vandermonde equals numpy.vander, then brackets x, then comma n+1. n+1 is going to be the dimensions of our matrix. At first, this might look complicated, but all this is doing is preparing our data so we can fit a polynomial curve to it. What the Vandermonde matrix does is it takes our input values x and generates multiple powers of those values. So instead of just using x, we also create terms like x squared, x cubed, and so on. Each column of the matrix represents one of these powers. For example, if one of our engine sizes was 2, the Vandermonde matrix might turn that into 1, 2, 4, 8, and etc. Which corresponds obviously to 1x, x squared, x cubed. These extra columns give the model the ability to create curved prediction lines instead of just straight ones. Perfect. Next, we solve the system equations that gives the best fitting polynomial. A equals x_Vandermonde dot t, which transposes the matrix, and then multiply that with at x_Vandermonde. B equal to x_Vandermonde dot t, so transpose again, at y, and theta star equals numpy.linalg.solve AB. Now let me explain this. This part is performing the mathematics that finds the optimal coefficients for the polynomial. First, we calculate two matrices, A and B. These come from something called the normal equations. In simple terms, this is the method we use to find the curve that best fits the data. The goal is to minimize the error between the predictions and the real data points. So finally we solve the equation using theta star equals NumPy.linalg.solve AB, and this will give us the values of the coefficients for the polynomial model. So these numbers determine the exact shape of the prediction curve that best fits the data. Great. So this calculates the coefficients of the polynomial that best fits our data. So next we create some new x values that we will use to draw the prediction line. Pred x, as in prediction x, equals numpy.range 0, 16.1. We need to do this as we will be extrapolating the data or going outside the x values we are given. This command will create a numpy array from 0 to 16 going up in increments of 0.1. Then we'll convert these values into another Vandermonde matrix so we can apply our polynomial model. Pred x Vandermonde equals numpy.vander pred x n+1. Then we just multiply this by the coefficients we just calculated. Predict matrix theta star times the pred x Vandermonde. Then use predict matrix equals, and then in square brackets we're going to create a list of the sums of each row. numpy.sum for I in predict matrix. This gives us the predicted fuel efficiency for each engine size. This command specifically is done by adding up all the values inside the singular polynomials, so evaluating for every x we have. Perfect. Now just to visualize the results. First we plot the prediction line, plt.plot. Then pred x, predict matrix, label equals prediction line. Then we plot the original data points, plt.scatter xy, that will become a scatter plot of the original data, and then a nice line of our predicted line data. Finally, we need to add labels and a title so we can clearly see what is happening. Then to display the graph, plt.show. Perfect. Now when we run the program, we can see the data point showing the relationship between engine size and fuel efficiency. Then we can see the prediction line that our model creates. Because the program is inside a loop, it actually runs several times with different values of n. Each time it runs, a new graph appears. In the first graph, the model is very simple, so the prediction line is closer to a straight line. As n increases, the polynomial becomes more complex, n powers of x in the polynomial, which allows the prediction line to curve more and follow the data more closely. So as we go through the graphs, we can clearly see how increasing n changes the shape of the model. The prediction line starts simple and then gradually becomes more flexible as the polynomial degree increases. Also showing that complex is not always better, as the higher complexity have massive tails. This is useful because it helps us understand how model complexity affects how well the model fits the data. This is the core idea behind machine learning. We give the computer some data, it finds the mathematical pattern that best explains that data, so we can then make predictions. And that is all there is to it. This is the first step in understanding how machines learn from data, and in the next videos we will keep building on this and explore more machine learning techniques. If you found this video helpful, please like the video and subscribe to the channel, as it really helps support the channel, and thank you for watching, and I will see you in the next one.